This is section 2.5, Inequalities. Part 1 here, solving inequalities graphically. Since we'll be solving linear and nonlinear inequalities, we will use the crossing graphs method to solve all of our inequalities. That's actually not quite true. In fact, in our first example, we're going to use the single graphing method. It comes down to, are you comparing to 0 or not? So the method for solving f of t greater than g of t or f of t greater than equal to g of t. Now, if you had something like a is less than b, and you wanted to turn one of these, just change it around. If a is less than b, then that means b is greater than a. So here's your method for solving the greater than or greater than equal to. Step 1, enter f of t into y1 and g of t into y2. Now we've done this several times, so it shouldn't be that difficult for us anymore. Step 2, find where the two graphs intersect. This is done with second trace, remember that's calc. So be aware that there may be more than one point where the two graphs intersect. So you might have maybe even possibly 3 places where it intersects. And that's where the left bound and right bound is going to help you out. Step 3. The solution is a set of all points where the graph of f of t is above the graph of g of t, because we wanted the greater than. Now if it said less than, you would want to find where f of t is below the graph of g of t. And step 4, include the x values of where the two graphs intersect if the original inequality was greater than or equal to. So step 4 only takes place if you're doing this one. Now note, if we're looking at f of t greater than 0 or f of t less than 0, f of t greater than or equal to 0 or f of t less than or equal to 0, we can use the single graph method. Okay? And we'll actually illustrate that with our first example. So our examples. Number 1 says solve for x. Round your final answers to 4 places to the right of the decimal point. We've got x squared plus 4x minus 7 greater than or equal to 0. Our solution. Since the expression is compared to 0, we can use the single graph method. So step 1, we're going to enter f of x equal x squared plus 4x minus 7 into y1, then quit the screen. Okay, let's go ahead and do that then. So let's see, take out the calculator. Okay, y equals, we're looking at x squared plus 4x minus 7, and then we quit the screen. Okay, now step 2 says find where f of x crosses the x-axis. So this is done with the second trace, which is calc. So you're going to get the following screen. Okay, notice there are 2 places where it's crossing. So there are 2 x-intercepts. For the intercept on the left, I use my lower bound of -8 and upper bound of -4. And for the intercept on the right, my lower bound was 1 and my upper bound was 2. Now, of course, these may not be unique, because remember, you want to get close to that and close to that one. So in both cases, my guess was the calculator's guess. So if we actually do this, okay, so second calc, I'm doing the 0. Okay, for the left bound, again, let me try this one over here. I said I was going to use -8 and -4. So let me enter in -8. And then for my right bound, -4. Okay, notice I am capturing the intercept that's on the left. So the guess of -4, sure, why not? So my 0 that I have there is -5.3166 to 4 places. Okay, then if I do it again, second calc, again I want to do the 0. My left bound, I said I was going to use 1 and 2, so 1 for the left bound, 2 for the right bound. My guess, I'll use the calculator's guess. So I get 1.3166 to 4 places. Okay? So again, there was my left intercept. And here is my right x-intercept. So I had -5.3166, 1.3166. Okay. So the 4 places, again, those are the x-intercepts. So we've taken care of where they're equal. So steps 3 and 4, since our inequality was greater than or equal to, we include the two x-intercepts. So our solution is x is less than or equal to negative 5.3166 and x greater than or equal to 1.316. Because again, remember, going back to our graph, we wanted it to be greater than or equal to 0. That means we wanted the piece of the graph which was actually above the x-axis. If it had said less than or equal to 0, it would be between negative 5.3166 and 1.3166. Okay? So again, remember, greater than 0 means above the x-axis. Less than 0 means below the x-axis. Example 2. The height in feet of a projectile t seconds after being thrown into the air is given by s of t equals negative 16t squared plus 100t plus 15. During what time interval after being thrown into the air is the projectile at least 130 feet above the ground? Round your final answer to the nearest hundredth of a second. Okay, at least 130 feet means greater than or equal to 130 feet. So we will include the endpoints that we find. So our solution. So for our preliminary step, we get the right window settings. Because notice 130 feet, remember our y max only goes to 10 by default. So for x, negative times do not make sense. I'm going to have my x min be 0. And I've arbitrarily chosen x max to be 10. I'm assuming that this can happen within 10 seconds. And I left my x scale at 1. Okay, for the y's, I let the y min be 0 because, again, negative values of y says that went below ground, like it's sunk into a well. And for the y max, well, I'm trying to get to at least 130 feet, so I'm going to pick something greater than 130. I arbitrarily chose 150, and my y scale was 10. So let's go ahead and do the Windows settings. So let's quit that. Let's clear out the y equals. So let's quit that. And our window, okay, x min 0. Again, I kept my x max at 10. I'm assuming this can happen within 10 seconds. Okay, my y min will be 0. I don't need negative heights. And my y max, again, something bigger than 130. Again, I arbitrarily chose 150. And my y scale was 10. Okay, and then we quit that. Okay, so I've taken care of a preliminary step to make sure I can see my graphs. So now, that's what my window should look like after I set my settings. So step 1, enter s of t equals negative 16t squared plus 100t plus 15 into y1 and 130 into y2, and then quit the screen. Okay, so let's go ahead and do that. So y equal, so negative 16t squared plus 100t plus 15. Whoops, I got 5 instead of 15. 15. Then just press enter to go to y2, and that's the 130. And we quit. Okay, remember for y2, or excuse me, step 2, we're going to find where the graphs intersect. Remember, that's second trace, and you're going to choose choice 5 for intersect. And again, notice there are two places. If you think about what's going here, why are there two places where it's 130 feet above the ground? Remember, once on the way up and then on the way down. So let me get caught up again. So second calc, which it didn't. Okay, that is y1. See, I must have done something wrong. Let me quit. I'm just going through all this nonsense first. Okay, let me quit. Second calc, choice 5. That is y1. That is y2. Okay, let me guess this one on the left first. So for my guess, I don't know, I want to get, because notice there's no left and right, so let me go to the left of it. I'm just going to go ahead and put in 0 as my guess. So, and notice it's at that left point. So 1.519345 and so on. See, we're going to how many places? Nearest hundredth. So that's 3 places. No, excuse me, 2 places. So 1.52. And then if we do it again, second calc, intersect, choice 5, that is y1, that is y2. Okay, for my guess, again, I want to come over here, so 1, 2, 3, 4, 5. Let me guess 5. And the point of intersection looks like 4.73. So there are 2 points of intersection. To find the first point, again, I guessed 0, and for the second one I did guess 5. So for the first point, again, 1.52. For the second point, 4.73. So because it should say at least 130, we're going to include those 2 points. And again, the blue graph is above the red graph between those 2 values. So since we want to know when the projectile is at least 130 feet above the ground, we're going to include the intercepts. So 1.52 less with a t, less with a 4.73 seconds after being thrown into the air. And again, going back to our graphs, you can see that's where the blue graph is above the red graph. Number 3. The population of Wonderbeast in Blue Bottom Mountain State Park is given by P of t is equal to 1,000 times 1 minus 2 raised to the negative 0.08 t all over 2 raised to the 0.08 t, where t is years since 1980. The population is considered viable as long as there are at least 200 Wonderbeasts in the park. During what years was the population of Wonderbeasts viable? So again, there's that word at least. That means greater than or equal to. So our solution. Again, as one step, I got to step my window. So it does not make sense for any values to be negative, so x min and y min should both be 0. Okay, so since t, which is again x on the calculator, is time since 1980, t equals 40. It will take us a few years into the future, right? If I had 40 of that, what is that? The year 2020. So I'm going to let my x max be 40. I'll have my x scale be 5. So 5, 10, 15, 20. Now for the y's, we're looking at for when the population is at least 200. So my y max should be larger than 200. Again, I arbitrarily chose 250. And my scale is going to be 10 in the y direction. So let's go ahead and do those settings on the calculator and also clear out the calculator from the previous stuff. So let's quit that. Our y equals, let's get rid of it. Let's get rid of the y2. Let's quit that. Now let's do our window. Okay, so we keep our x min at 0. We said we're going to take our x max to 40. So 40. We're going to have our x scale be 5. Okay, we have our y min to be 0. And again, something past 200. I chose 250. Okay, and the scale for y is 10. So we can, which is what it already is. So we can quit that. Okay, now, again, that's what my window settings look like. So, step 1, enter that into y1, the p of t, and 200 into y2, and quit the screen. Okay, let's get to that stage. So, y equals, again, that's where we're going to put the p of t, the population. So, I've got, open the parentheses, 1,000, remember the parentheses were the numerator, open parentheses, 1 minus 2 raised to negative 0.08 t, get out of the exponent, close for the parenthesis that's there, close for the numerator, divided by, now this is just one expression so I don't need parentheses, 2 raised to 0.08 t, get out of the exponent, and just press enter to go to y2, which was going to be 200. Okay. Oh, and we're supposed to quit the screen. Quit. And then for step 2, we're going to find where they intersect. So we're going to do second trace and choice 5. Okay, so again, notice there are 2 places. Okay, there's going to be 2 places. So second calc, choice 5. Okay, that is my first curve. That is my second curve. Okay, let me go ahead and guess the one on the left. And again, for my guess to go to the left, let me guess x is 0. So my guess is going to be 0. And to 2 places, what do we got? 5.83. And if we do it again, second calc, choice 5. That's y1. That is y2. My guess. Okay, remember these are 5s, so 5, 10, 15, 20. I don't know, let's try 20. Looks like 23.19. Now, if by accident you didn't choose a value that was close enough to this and it took you back to this one, you have to go through it again. Usually, if you get past that hump, then you'll be okay. If you actually take the calculus class, you'll discover what would be a good choice to make sure you do in fact fall in the direction you're supposed to. So there are 2 points. Okay, again I used 0, and I actually did 20 when I was doing it live and in person. So, but on the slide I did 25. So again, the 5.83 and the 23.19. And we're wanting to be viable, so that means greater or at least 200. So we'll include those 2 endpoints. We'll include 5.83 and 23.19, and the blue graph is above the red one in between those values. So for steps 3 and 4, only whole numbers make sense, so 6 and 23. Now, going back to this, there are some people that say instead of rounding correctly, they would just drop the decimal part, which is called truncated. They would actually use 5 and 23. So 6 and 23, because whole numbers, because it's animals, makes sense. So 1980 plus 6 was 1986, and 1980 plus 23 is the year 2003. So between the years 1986 and the year 2003 is when the population is viable. Notice what it really means then for the population to be viable. That means the population can sustain itself. So before the year 1986, the population wasn't viable. It was in danger of dying out. And after the year 2003, sooner or later, the population of these wonder beasts will eventually die out. Again, it's years that we're using. That's why we use whole numbers. Okay, remember, don't use decimal years. Don't do 1985.4. I mean, that doesn't even make sense. It's not Star Trek. And that's the end of section 2.5.